Hey everyone! Welcome back to Bugnojutsu, where we decode the toughest problems with crystal clear intuition. Today, we're solving a problem that beautifully combines bitwise operations with backtracking recursion. It's from LeetCode, 2044, count number of maximum bitwise OR subsets. If you've ever struggled with how to approach bitwise questions using recursion, then stick around, because this one's for you. You are given an array of integers, and your task is to determine how many different non-empty subsets of this array produce the maximum possible bitwise OR value. A subset in this context means selecting some elements from the original array in the same order, possibly skipping some. The key point here is that subsets are considered different if the indices of the selected elements are different, even if the values themselves are the same. This means we're not just checking for value combinations, but also their positions within the array. The bitwise OR operation is a binary operation applied between integers. When combining multiple elements in a subset, their bitwise OR is calculated from left to right, by applying the OR operation between each pair successively. This gives a single integer result for that subset. Your goal is to identify the maximum OR value that can be achieved from any subset of the array. Count how many non-empty subsets produce exactly that maximum OR value. The challenge lies in exhaustively exploring all valid subsets, tracking the OR results, and identifying how many subsets reach the highest OR possible. Let's understand this with a small example. Nums equals 3, 1. All possible non-empty subsets of this array are 3, 1, 3, 1. Now let's calculate the bitwise OR for each. 3, the OR is 3. 1, the OR is 1. 3, 1, the OR is also 3, because 3 or 1 is equal to 3. Among these, the maximum bitwise OR we can achieve is 3. And how many subsets gave us this value? 2 of them, 3, and 3, 1. So, the answer for this input would be 2. That's exactly what we need to compute, how many subsets result in this max OR value. The first thing we need to do is to figure out what the maximum possible OR value is. And that's simple, we just take the bitwise OR of every element in the array. This gives us the highest value that any subset can reach, no matter which elements we pick. Once we have this maximum value, we move on to exploring all possible subsets using a classic backtracking approach. At every element in the array, we have two choices, either include it in the subset or skip it. As we move through the array, we keep track of the OR of the current subset. Once we've considered all elements, we check, does the OR of the current subset match the maximum we computed earlier? If yes, we count it. If not, we discard it. This way, we explore every subset, and only count the ones that give us the maximum OR value. Even though we're using brute force, it's efficient and elegant for this problem because the array size is small enough to handle it. Now let's talk about complexity. Since we explore every subset, and there are 2 power n possible subsets for an array of size n, our time complexity is O, 2 power n. For each subset, we do constant time operations, mostly OR checks and comparisons. In terms of space, we're only using the recursion stack, which goes as deep as the size of the array, so the space complexity is O, n, due to the recursive calls. The beauty of this problem lies in how it teaches bitwise reasoning through a recursive lens. Many developers struggle to merge low-level bitwise logic with high-level recursion or backtracking, and this problem is the perfect practice for mastering that. It's also a great reminder that not all backtracking problems involve sums or permutations. Sometimes, it's about logically combining values, like or and making decisions based on that. So if you're preparing for interviews, especially for product-based companies, this problem is a must practice, because it tests both bitwise fundamentals and recursive thinking. That wraps up our walkthrough of count number of maximum bitwise OR subsets. If you learned something new, make sure to like, subscribe, and hit that bell icon so you never miss a deep dive from Bugnojutsu. And hey, if you want a code breakdown, dry runs, or even visual animations of this approach, let me know in the comments below. Until next time, keep solving, keep growing, and stay sharp. This is Bugnojutsu, signing off.